A three-cylinder engine was once a punchline, meant for tiny city cars, not tearing up supercar records. Now imagine that same configuration, stripped of its camshaft, somehow generating 600 horsepower and upending a century-old belief that power demands size. This is not science fiction. It is a Swedish reinvention that puts everything we thought we knew about engines on the line. So, how does the tiny, friendly giant threaten the reign of the V8, and what is the hidden genius that makes it possible? For generations, the V8 reigned as the symbol of automotive power. Its deep rumble and oversized cylinders became the heartbeat of everything from American muscle cars to European exotics. Car culture celebrated displacement. More liters meant more respect, more speed, more bragging rights. Meanwhile, the three-cylinder was quietly tucked away in the world of economy hatchbacks, prized only for sipping fuel and fitting into city parking spots. Numbers told the story. A typical three-cylinder, like the one in the Toyota GR Yaris, managed around 268 horsepower at best. V8 engines, by contrast, routinely pushed past 500, sometimes 700 horsepower, but always carried the bulk and the thirst to match. The idea of a tiny triple threatening the V8's legacy sounded like a joke, or maybe a dare. Yet as emissions rules tightened and technology leapt forward, the old equation, big engine equals big performance, started to look less like a law of nature and more like a comfortable myth waiting to be challenged. Inside the tiny friendly giant, the camshaft is gone. In its place, every valve is controlled by its own electro-hydraulic-pneumatic actuator. Instead of a spinning rod dictating when valves open and close, a computer now commands each valve independently. Timing, lift, and duration are tailored in real time for every cylinder. This unlocks the ability to switch instantly between the Miller cycle, which squeezes out extra efficiency by closing the intake valve late, and the Otto cycle, tuned for maximum power. With no throttle body, air flows directly into the engine, cutting pumping losses and boosting efficiency by up to 20%. One Koenigsegg engineer described it as giving the engine a brain for every valve. The result is a level of control that simply wasn't possible with cams, setting the stage for a turbo strategy that is just as unconventional. Turbo lag has always haunted high-performance engines, but the TFG attacks it with a strategy only possible when every exhaust valve is under digital command. Each cylinder has two exhaust valves. One channels gases to a small turbo, the other feeds a larger turbo. At low engine speed, the computer sends all the exhaust through the first set of valves, firing sharp, high-velocity pulses straight into the small turbo. This spins it up almost instantly, delivering boost without hesitation. As engine speed climbs, the second set of valves opens and feeds the big turbo with a surge of exhaust flow. The transition is seamless, managed entirely by the Freevalve actuators. There is no mechanical wastegate and no laggy variable geometry. The result is a tidal wave of power, building all the way to 29 pounds per square inch of boost. It is a system that lets a three-cylinder engine punch far above its weight, with boost on tap at any speed. Pairing the tiny friendly giant with Koenigsegg's axial flux electric motor transforms the Gemera into something never seen before. The electric motor alone delivers 800 horsepower and over 1,200 Newton-meters of torque, instantly available from 0 revolutions per minute. Combined with the TFG, total system output climbs to 1,400 horsepower, launching the car from 0 to 62 miles per hour in just 1.9 seconds. This is raw power. The hybrid layout allows engineers to tuck the entire powertrain low and central, freeing up cabin space for 4 adults and their luggage. Noise, vibration, and harshness, longtime weaknesses of three-cylinder engines, are tamed by balance shafts, electric assistance, and Freevalve's precise control. The result is a deep, resonant exhaust note that is more inline-six than economy car buzz, with an electric punch that makes acceleration feel endless. The packaging and the sound together create an experience that is as refined as it is brutal. Claims of carbon-neutral performance rest on the TFG's ability to run on renewable methanol, with life cycle estimates suggesting emissions as low as 20 to 50 grams of carbon dioxide per kilometer, numbers that rival or even beat some electric cars depending on how the methanol is sourced. But sustainability is not just about fuel. Reliability. Engineers point out that Freevalve's electro-hydraulic-pneumatic actuators face mechanical and thermal stresses that traditional camshafts never had to endure. There is no long-term data on how these actuators handle years of high boost, high RPM abuse. Without a proven record for wear and maintenance, the promise of a greener, lighter engine comes with real questions about durability and serviceability. When production plans for the Gemera were finalized, Koenigsegg surprised the market by offering a second powertrain, the Jesko-derived Hot V V8, paired with the same dark matter electric motor. This combination pushes total output to a staggering 2,300 horsepower. Early interest from buyers leaned heavily toward the V8, drawn by its familiar thunder and headline numbers. Yet none of this would be possible without the groundwork laid by the TFG. Its compact size and hybrid integration made room for both the dark matter motor and the V8, proving that radical innovation can open doors, even if tradition still calls the shots. Koenigsegg's TFG proves radical innovation can shatter old limits. 600 horsepower from 3 cylinders, ready for renewable fuels. The next leap in performance isn't bigger, it's smarter. What leap comes next?